Okay, so I want to talk about TamStat 2018, and that's what you have seen. Basically, I want to talk about the development of the application and the challenges and lessons that we learned. Essentially, if you haven't guessed it, Stephen has written a nice statistical core, and we tried to apply Dewey to it. So before I start, I want to set the focus and make it clear. What I will be showing has been developed in my server 3 because that was readily available, but there's more because this code can be run within Dewey. And that's not all, because so far we have implemented, I think, 6 out of 10 wizards that are available in TamStat. So, well, basically, I think Morten or Brian spoke to me and said, why don't you convert TamStat to a Dewey or my server application? And I thought, well, great, I'll just take the statistical core and wrap it into nice GUI, and that's it. Easy job. Well, personally, I'm a statistical amateur. My capabilities are sufficient to calculate the average of the numbers 2 and 4, but you don't want to challenge me further. So I had an introduction into TamStat, and I thought the easiest starting point would be the so-called summary wizard. And basically what that does is that it is the equivalent of sum S or sum reduction for mouse movers. The UI that Steve had implemented is a screen like that, where he offers various statistical functions categorized into different categories, and the user can select if he wants to apply them or not. As I browsed around through the workspace that was given to me, I noticed there was a namespace summary which had some of these functions in it and some others. Interestingly, this does not correspond one-to-one. For example, you have in the position category, you have 1 quartile, and 3 quartile, but there's only 1 quartile function. Or there's a standard deviation function, but which we don't see in this list. So obviously something more is going on here. We cannot just use the list of functions to generate a list of checkboxes. When I designed the new UI for that, it would probably not be good to hard code this list. I wouldn't want to edit my code again, so this had to be flexible enough to cope. So we were uncertain about the dimension and shape of things, and also wanted to be flexible. The solution was I had the idea to use an external JSON file in which I defined these things. So for example, here is an excerpt. There's a group of things which is called measures of position. Their internal code or title is position, and the group contains these functions. Okay, nice. But we saw that some things did not correspond one-to-one. Function names did not correspond to the names that we saw in the checkboxes. And with the quartiles or percentiles, we also had arguments that were passed in the call. So I had to extend this a little bit. There's a possibility to define a function name here in the description, and also there's the optional possibility to have items not selected in the UI. So there's a default selected state element which can be defined to control whether the thing is selected or not. And all that, here's some code, is doable very easily with quad.json. We read the file, and also handling these optional elements is easy. I decided I want to, when I use the thing internally, I want to have a value for every element here. So this statement will ensure that wherever the value is not defined, it is set to the default value of true. And the same for the description. If we don't find the desk element, we use the function name as the default. So to summarize that level, well, welcome to the 1357th edition of JSON jokes. But obviously I meant to say that. So my first learning, not of this project, but in general, is use quad.json. In everything I do, I find applications for quad.json. I don't know how it comes, but that's just the effect of life. You can use quad.json for everything. The second lesson was don't, separate your code and your UI. And we didn't want to rely on names of functions to build the list there. And avoid hard-coded lists. So I also wanted to look at the screen in practice. There it is, okay. So we select a variable here, select functions that we want to apply, and then we can calculate something. The new implementation is in a two-tabbed screen. Actually, here you see the data set that is examined. The data set contains more data than fits on the screen, so you can select the fields that you want to see. You can sort based on individual fields. And of course, you can also look at all records at once. But the statistics is what we were interested in. So here we have the selection of all variables. There's the list of functions, which is generated from this JSON file. And that's the default selection based on the default select state. If I click here, it will perform the calculation. And then I can do additional calculations. For example, I can group data by sex, and it will just add another row of results. You see that's the second run. We have the height for female and male. So that's the new summary wizard. And the next screen is the confidence interval wizard, which we saw briefly during Steve's presentation. I also want to do the old-new comparison there. So the idea here is basically what's the confidence interval if we want to predict the height of a participant in the study with 80%, with 90%, 95% secure reliability, or with 99%. And you see, if you ask for more reliability, you get a broader interval. And with less reliability, the prediction can be narrowed down. If you want to know more statistical details, ask Stephen, and he can give you a 1-hour lecture this evening.
Actually, use the word confidence rather than reliability.
Yeah, right, sure.
Okay.
Sorry.
Not a big deal.
Okay, so we can repeat the same here. We have the list of variables. There's a list of confidence intervals that we expect. And you see how the results are immediately adjusted if you define additional input, for example, here. There's additional information throughout the system. For example, here we indicate with the minus sign that this value is a number. So a second number would be subtracted, and we would then make a statement about the confidence interval of the difference of these numbers. So as I started work on this application, or on this screen, it became obvious that we needed to rethink the whole integration of things, because I couldn't just take the old code and embed it into some new fancy UI. But if you watch what happens, there's a lot of interaction. If I select an alternative data series here, for example, we want to predict shoe size. As soon as I enter the shoe size, you will see that the 3 fields which describe the series will be updated. So there's a lot of back and forth and intermediate calls of Steve's code. So we had to rethink how we should do that. So we really, I think, during that experience, learned to appreciate the separation of code and application. And so the situation that we had in the beginning was there was a front end, the quad WC front end, and the business logic, the statistical core functions that you can use in the workspace. And there was some overlap between them. And we had to tear that completely apart to have a front end, a back end for the business logic, and then we injected a layer like the API, which would communicate or allow communication between the two. So the front end was the part that I was responsible for. Clearly, as I'm a statistical amateur, Stephen had to take care of the business logic. And the API design was the result of intense negotiations and discussions. And finally, somebody had to take ownership and responsibility of that part. And basically, it's Stephen, because he provides an interface to his application through that. So how do you design an API? Ultimately, we ended up with something very simple. You call an API like, for example, the confidence interval wizard API. Well, we've abbreviated that a bit. You pass an argument to it, and you get a result. And the result, as well as the argument, are namespaces. because we found that's the most flexible way that we can think of in order to pass data or to exchange data between the different layers that we have. There's one variable which will always be defined, that's the event variable, because that gives the API instructions what to do. Like, for example, there's an init event to which the API will respond with a list of functions that it could perform. But different functions may require or also set different variables in the result. So you see we are returning a namespace also as a result. Since we are passing refs, we could also do without returning the namespace. It's a ref anyway. But we thought it might be useful to have the option to return something different from what you received. This way we can easily extend the functions in the different layers, in the business logic, for example, without having to worry about adopting interfaces. Syntax of functions will not be changed if new methods are introduced. It has helped to decouple the development process. Steve was able to work on his part of the code, whereas I could independently work on mine. In cases where he wasn't able to return results yet, I did some simple stuff like calculate an average to assign a value that I was expecting from him. When he had delivered his code, I just took out my average calculation. And the advantage of using this namespace approach is that it might be translatable to my favorite format. And so possibly, if you do that, you can run the backend with a JSON server and scale the application even more. But if you want to do that, be careful about including arrays in the namespace, because that's not translatable into JSON. So to summarize the experience, things have changed a bit. And now if we tackle a new wizard, a new challenge, we first discuss the API and agree about input and output that's going to be exchanged. We examine the user interface and decide about the interaction that is needed and the event values that will be required. But we also saw there is a need to be dynamic in that whole process. There are no fixed and hard rules how to define an API and where to draw borders. For example, if I want to only accept character value in certain input fields, do I call the API and ask it to validate my field, or do I do that on the front end? I think every approach has its benefits, and you can have arguments and reasons why each of these is useful. So you have to decide that in the individual situation. We think it has helped to clean the back end, make it more relaxed, because it doesn't have to worry, for example, about data formats. We don't need the mean function to worry about receiving a character vector, because the API will have taken care of that. And it has also simplified debugging and testing. I want to look at the fundamental difference that we saw. I mean, we have Quad WC. That's a small and cozy world. You know what to expect there. And on the other side, we have the cold and brutal universe. What does that mean? Well, you either run Microsoft Windows on your local machine, and you know what resolution you can expect, at least in most cases. On the other hand, if the application is run by users out there, you may face an infinite permutations of resolutions, screen sizes, operating systems, and browsers. So there's more stuff out there that you have to be prepared for. If you design a Windows user interface, often you end up counting pixels, and then you carefully position the controls on your screen. Whereas the HTML approach to building user interface is more to group things together and then flow them on the screen. Well, what's the reward for doing this? We have one set of business logic. There's one API built on top of it, and we can call that API from the My Server application, can run it in HTML renderer, and Stephen is also adopting his TamStat Classic, the Windows version, to use the API also, so that it can benefit from the developments he does to the kernel. And that's more or less the end. Thanks.